So when we'd originally looked at our exponential functions, we had done a few solving problems. Let me redo one of those now. So we had previously done this. 2 to the x is equal to 8. And the way we did it in that first section was I said, okay, well, get the same base on both sides. Instead of 8, I'm going to write that as 2 to the third. And then what I said back then was, as soon as you have the same base on both sides, just cancel them, just ignore them, and set the exponents equal to one another. But now we actually know what's going on. We are taking log base 2 of both sides in order to get these two to cancel. But that amounts to the same thing as what we had done before we even knew logarithms existed. And so that will leave us with an x on the left-hand side and a 2 to the and a 3 on the right-hand side. And so let's see here, we get x equals 3 as an answer. Now on these, I never mentioned checking anything because the domain of an exponential function is all real numbers. You're welcome to check and make sure you did the problem correctly, but you don't have to like you have to with the log solving problems. The reason I wanted to redo this one is we could have something very similar to it. Let's say solve 2 to the x equals 7. And the problem there would be we couldn't have done this before because we don't know how to rewrite 7 as 2 to some power. But now that we know logarithms, that's not really a big deal because we know we can just take log base 2 of both sides. On the left-hand side, they cancel, we get x. On the right-hand side, they don't cancel, but that's not a big deal. We've accomplished our goal here. We've gone ahead and solved for x. That's all we needed to do on this problem. We were just trying to solve, and we've done that. Now, you might have things like this come up on the homework or on the quiz where it might look like a problem that's easier to do, like the first one I did, but in actuality, it may be something where you just need to take log of whatever of both sides, and maybe you get an uglier answer. Not a big deal. So long as you've solved for x, that's what's important here. And let's do a more complicated one as well. Let's say I want you to solve 3 times the exponential 4 raised to the x minus 5 power equals 10. All right, so first step, I'm going to go ahead and divide both sides by 3. And it'll give me a 10/3 on the right. Now to get rid of that 4, I'm going to take the the logarithm with base 4 of both sides. So log base 4 of both sides here. That's going to cancel the exponential 4 on the left. Leave me with an x minus 5. Now I have log base 4 of 10/3 on the right-hand side. And to get x by itself, I can go ahead and add 5 to both sides. And that'll do it here. Again, you can check this if you want to. I'm not going to, but you can check it if you'd like to. But you don't have to check it unlike logarithms. So remember, exponential functions, they have a domain of all real numbers. So if you're confident in your work, you don't need to worry about does something violate the domain because the domain of an exponential is everything. Any answer you get, so long as you got it legitimately, is going to be an appropriate answer.